Okay, so last time we saw how to represent the terms on a two variable and three variable Carnot map. We looked at their basic layouts and we saw how to represent the terms on the basic Carnot map, how to draw a basic Carnot map. Okay, I'm presenting my screen. You can let me know if you have any problems in the last lecture. Are you able to see my screen?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So please let me know in case you have a problem in any of these concepts that we went over last time. So we had also discussed the standard forms, the canonical forms and their differences, right? And we had seen that they are duals of each other, right? And then we had seen the basic layout of a two variable map and how to represent terms on the same. Then we had also seen the layout of a three variable Carnot map and we had also seen how to represent terms on the same. Okay, so today we are going to start up with a four variable Carnot map. So what you see on the screen is how a four variable Carnot map is drawn. This is the basic four variable Carnot map. So please see, we are assuming that our function f, the Boolean function f now is a four variable Boolean expression containing the Boolean variables w, x, y, z. Okay, so I have taken this axis to be wx and this axis to be yz. Okay, so if I have four Boolean variables w, x, y, z, I take the first two variables on this axis and the next two variables on this axis. Okay, now obviously how many cells are going to be there in the four variable Carnot map?
16 squares.
2 raised to the power of 4, that
4.
is 16, each corresponding to a input variable combination of the truth table that we had seen earlier. Okay, so if you have practiced the truth tables carefully, you will now be able to corroborate what you see on the screen next, and I'm going to tell you. So please see, since there are 4 rows and 4 columns, so 4 into 4 makes 16 squares. For these 4 rows, I number them as 0, 0, 0, 1, 1, 0, 1, 1. Okay, in the normal numbering, I can choose these numbers. I can choose these numbers to represent four unique rows to identify 4 rows. Yes or no?
Yes,
Yes.
ma'am.
Yes, ma'am.
Okay, similarly for the columns. Similarly for the columns. Yes or no?
Yes, ma'am.
Ma'am.
But
Yes, ma'am.
But in the previous class, we had seen that actually, in case of a Carnot map, when we are using these combinations only. Okay. For example, last time I had 4 columns for which I had chosen 0, 0, 0, 1, 1, 0, and 1, 1. So the combinations were same, but we took a skip here and then this was 3, if you remember. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Right. So please see, the same thing we are going to do today in the four variable Carnot map. So you'll find this is actually 0, 1, skip 2, then 3. Okay. Similarly here 0, 1, skip 2, and then 3. Okay. Right. This is how we list the terms. Why so? Because this is how we solve it. So you need to memorize this. You need to memorize these uh, numbers. So what you will have is eventually, please see, 000 here means WZ, I'm sorry, W dash X dash, Y dash Z dash. Yes or
Yes,
no?
ma'am.
Yes, ma'am.
Yes, ma'am.
Right. Next is gonna be, please speak up, Disha.
W dash X dash Y dash Z.
Very good. Next, Nandini.
W dash X dash Y Z.
Next, Kashish. Kashish is there. Okay. Lynette.
W dash X dash Y Z dash.
Excellent. Who will answer next?
And can I?
Nandini. Yes.
W dash X Y dash Z dash.
Yes. Very good. So you can see what is this term. This is actually
Zero.
0, 1, 2, 3. Okay.
Two.
0, 1, 2, 3. So accordingly in this diagram, you can see the min terms 0, min term 1, min term 2 and min term 3 listed. Okay. So so you know now how to read these Boolean uh, terms corresponding to these binary numbers now. Yes. So
Yes.
I'll just go over the numbers with you now. So this will be
Zero.
equivalent to the decimal 0, 1,
Zero. One.
2,
Two.
3,
Three.
then
Two.
4,
Four.
5,
Five.
5, 6,
6, and
and
7.
7.
So this is, as you can see, this is exactly like the three variable Carnot map. Okay, this is
Yes,
up till
ma'am.
here, it is exactly like the three variable Carnot map. Okay, now after this, after I've done 7, now to place 8, I'll do another skip here. Okay, I'll do another skip here. So this will be 8. Why? Because please see, this is 1 0 0 0. What is 1 triple 0? It is 8.
Eight. Eight.
Yes. So this is 8, 9, skip
Nine.
10. This is 10. This is 11.
11.
11,
Okay. Then 12,
12.
13,
13.
13,
skip 14,
14,
and
and
15.
15.
Okay. So this is what I need you to, these two representations are what I need you to know by your heart. Okay. I mean, you can obviously, just remember these and then lay out, but it takes a lot of time that way. So it is always handy to memorize these things. Okay.
Yes, ma'am.
Next, we are going to see, before we start up with the actual, uh, solving of Boolean expressions using the Carnot maps, let us just have a look at the five variable Carnot map as well, although it is not in your course, but you can just have a look at how will we construct a five variable Carnot map. So for that, I'm taking you again back. Once again, I'm taking you to the four variable Carnot map. If you see carefully, you will be able to notice what is a four variable Carnot map. It is actually composed of two three variable Carnot maps. It is a joining of two three variable Carnot maps. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
No. So similarly, what will be a five variable Carnot map? It will be joining of two five
4
variable
variable.
four variable Carnot maps. Okay, so I take AB here and CDE here, where the five literals in our Boolean expressions are A, B, C, D, E. Okay, so and this is the alternate representation for this five variable Carnot map, where you will be able to visualize it better. So you can see that uh, for A, for A, we make one four variable Carnot map with BC and DE, and for A dash, we make another Carnot map with BC and DE. Now, what this means is that how do we come to this? How do we come to this? Please see. If you remember the table, I'll just show you. Okay, let me just go to the four variable truth table. Just sharing the screen from another PPT for your reference. Please let me know when you can see my screen. Can you see?
It's visible, ma'am.
Okay, yeah, thank you. So these, if this is the truth table for a four variable Boolean expression, yes or no?
Yes,
Yes,
ma'am.
ma'am.
So we are going to be focusing on this part. We are going to be focusing on this part. Okay, the first four uh, columns here. I want you to focus. Now, please see that how is a four variable truth table constructed. That means how does this how does this counting actually how is this counting done? Okay, let me just uh, take another slide and show you. So you can see, suppose I have a single Boolean variable x, then what are the combinations that I can have?
0, 1.
Yes, okay. Now suppose, अरे ये क्या हुआ? Now suppose I have two Boolean variables x and y. Okay, what are the combinations that I can have? 0, 0,
0,
0, 1.
0,
Yeah.
0, 0,
How,
0, 1.
yes. How do I come to them? Please see these two numbers, Boolean numbers that I had for the single Boolean variable. What I'm going to do is I am actually I'm actually going to append them with a 0 first. Okay. And then I'm going to take them again. These 0 and 1, I'm going to take them again. I've taken them again. And now I'm going to append them with a 1. Aren't this the input combinations that you are used to seeing so far?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Now let us try and construct the input combinations for three variables. Okay, the values that three variables can take. So I'm going to copy this. Okay. So I've pasted them twice. Okay. And now please see what I'm going to do. I'm just going to put a 0 before the first 4 combinations, and on the repeated set, I'm going to append it with 1. So you get your 8 combinations that we use in our truth table. Is this clear or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. Now let us construct the input combinations for the 4 variable Boolean expression. Okay. So I'm going to take these 8 and just copy them here. So you can try working with me on a piece of paper simultaneously to see that this is what you will get. So what am I going to do this time? Tell me. I'm going to put a 0 in the most significant position in the first 8 combinations.
Yes,
Okay.
ma'am.
And 1 in the rest of the in the repeated set. Okay. To get the next 4-digit input values. Okay, is this clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Right. So let me just write down the numbers for you. So this is the decimal equivalent for number 1, 2, 3, 4, 5. I'm sorry, this is we start since we start from a 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now, if you're getting, if there is a iota of doubt, let me clear that by showing you that in any case, when we are dealing with the decimal numbers, how do we get our next set of numbers? What is decimal number system? Decimal number system is the number system that we use, the human beings use in our common day-to-day life for our numerical needs. Okay, so this is the number system that you've learned to work with in your schools. Now, since this number system contains a basic 8 I'm sorry 10 digits. Okay, since there are a total of 10 digits in this number system, so that is why it is known as decimal number system. Decimal because a deca means 10. Okay, a deca means 10. So these are the basic digits in our number system. Okay, now what are the rest of the numbers? They are just made by repeating these numbers. Please see. So when I need to get the next set of numbers, what I simply do is, even in the decimal number system, please see, what we do is we just put a 1 here. Okay, this is, I just start appending them with 1 in the most significant way, position, I'm sorry. Okay, and I get the next 10 numbers. Then the next 10 numbers, how do we get them? We
By appending two.
by appending 2 and so on, so forth. Is this clear now? Is this clearer now? I should
Yes,
ask.
ma'am.
Yes, ma'am.
Yes.
Any problem, students?
No, ma'am.
No, ma'am.
No,
So you
ma'am.
can see that similarly, we can extend this concept. When we are dealing with 5-digit numbers, what are going to be, how many numbers are I going to have with 5 bits?
32.
32.
32. Okay. 16 of which are listed here before you. Okay. So you will append all these with zeros, and the next 16 numbers you will get by appending all these numbers by a 1 in a most significant bit. Please remember the most significant bit. Okay. Why? Because even in decimal number systems, when I took this as my base set, and if I would have just put 1 here, was this the same as 10? No.
No, ma'am.
Right.
No,
So
ma'am.
where do we have to augment the 1? We have to augment the 1 here. Here. Okay. In the most significant position. Is this clear?
Yes,
Yes,
ma'am.
Yes,
Yes,
ma'am.
ma'am.
yes, ma'am. Yes, ma'am.
Any problems now?
No, ma'am.
No, ma'am.
Okay, good. So this will also help you to remember these input combinations better, I think. Let me go back to my original slide now. Please let me know once you're able to see my screen. Are you able to see the screen?
Yes, ma'am.
Okay.
Yes, ma'am.
So how will a 5-variable Carnot map be made? By joining two, by joining two 4-variable Carnot maps. Okay. The first 16 combinations will come when A is equal to 0. Yes or no?
Yes,
Yes,
ma'am. Yes, ma'am.
And the next 16 combinations will come when A is equal to 1.
1.
1.
Okay. Any problem up till now?
No,
No,
ma'am.
ma'am.
Good. Okay. So now I am going to take you to, I'm going to take you to my PDF. Okay. The PDF of the e-lesson that I have authored on Carnot maps. From that PDF, we will be looking at the rules to group the ones in a Carnot map. Okay. I'm just going to take a minute, please, and then I'll return. Okay. I'm just taking a minute off. Yeah, okay, students. So please let me know once you can see my screen. Can you see my screen?
Yes, ma'am. Yes, ma'am.
Okay, good. Okay, so what we are going to look at first of all is the sum of products simplification. Okay. Okay, who will read for me today?
Dipali,
Yes, Dipali.
the procedure for obtaining a reduced sum of products Boolean expression from a K-map involves the following steps. Step 1. Form largest possible groups of adjacent squares containing ones. Care must be taken to cover all the minterms.
Now, yeah, please see. So the first thing is that what are we going to do? For sum of products simplification, the first step is to represent the expression in the Carnot map. Okay, the way we did in the last class. Okay, now after we have put in all the ones where they are required, okay, for each minterm we have put in a one where it is required. Then what is the next step? The next step is the actual first step of the simplification. So what do? We start grouping ones together. Now which ones to group together? The ones which are adjacent to each other, either horizontally or vertically, but not diagonally. Okay, either horizontally or vertically, but not diagonally. Okay, now what does it mean by saying the largest possible groups? So we are only allowed to make groups in the powers of 2. So I can make a group of 2 raised to the power of 1, that is 2 ones, 2 raised to the power of 2, that is 4 ones, 2 raised to the power of 3, that is 8 ones, and so on and so forth. Okay, I cannot make a group of 3, 5, 7, 6 ones. Okay, is this clear? And so on and so forth. Is this clear?
Yes,
Yes,
ma'am.
yes,
Yes,
ma'am.
ma'am.
Okay, now suppose I have 4 adjacent ones, then what this thing means is that, I'm sorry. So suppose I have 4 ones together, then I should not try and make 2 groups separately of 2 ones each. Instead, I should go in for the largest possible group possible at that stage, which is 4. Okay, why? This I'll let you know in a while. Is this clear?
Yes, ma'am.
Yes,
In
Yes,
any
ma'am.
ma'am.
case,
Yes,
in any
ma'am.
case, I'm going to be repeating these things. Okay. So, yeah, Dipali, you can continue with step 2.
Step 2. Write the product term corresponding to the group formed in step 1. The
So for each group that we have formed, the second step is to write a product term. Now please see, I'm not saying the min term now. Okay. Initially, we started with a canonical form, which is the sum of min terms form. Okay. What we want to do is we want to, reduce it and come to a simplified expression. Okay. So for each minterm, we put a 1 in the squares, we group them, and now for each group, I am going to write down a reduced term, reduced Boolean and term, okay, in my answer. Okay, now what happens in this answer? Yes, please read.
The identity law x or x prime is equals to 1 is used for this purpose to cancel the terms that appear in a group in both the primed and unprimed form. Step 3. Repeat
So
steps for
just a sec, yeah, just a sec. So now when I am writing the and term corresponding to one group, what I will do is I will cancel all the terms which have both primed and unprimed variants of the same Boolean variable. So you remember last time we had talked about that if there is a and a dash, okay, a and a dash, they cannot appear together. Okay, so if in that group I find that a and a dash both are coming, I cancel that. Okay, then b and b dash both are coming, I cancel that. Okay, c is coming only as c, then I retain that. Okay, just I'm telling you, please just listen to me right now, and then I'll explain it with an example. Okay, yes, next step.
step 3. Repeat steps for other groups. Each group yields a reduced product term which is O-read with the remaining product terms to obtain an expression in sum of products form.
Yeah, so the same procedure, that is the step 2, we do for all the groups. For every group we get one and term. Now all these and terms are put together and they are ORed with each other to get the final SOP expression. Okay, now let us see. Let us first uh, take some examples and convince ourselves uh, about the rules of grouping once again, what to do, what not to do. Yeah, Dipali, read.
Rules for grouping to obtain a Boolean expression in SOP form. The following rules are employed for grouping. Rule number 1. Groups can only include a cell containing a 1.
Yeah. So as we said that we need to, please see here, we need to form the largest possible groups of adjacent squares containing ones and not zeros. Okay, so we you cannot include a zero in a group. Okay, this is wrong, this is wrong. Okay, and grouping of only ones is right. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, next, Dipali.
Rule number 2. Groups may be horizontal or vertical but not diagonal.
Yeah, so again I told you, so suppose I have this kind of a Carnot map, two variable Carnot map, okay, where these one min terms have been marked as ones. So there is no grouping possible at all in this Carnot map. Okay, there is no grouping possible. What we will do is when we form its expression, we will just write the min term corresponding to this and this separately and just join them. That means that this expression cannot be solved any further. Okay, so we cannot group diagonally. The only kind of groupings that are allowed are horizontal and vertical. Okay, is this clear up till now?
Yes, ma'am.
Yes, ma'am.
Okay, next.
Yes, ma'am.
Rule number 3. The number of cells in a group must be a power of 2 only.
So this I explained to you. Yeah, please see. The first is a group of 2, then a group of 3 which is wrong. Okay, this is right, this is wrong. Then a group of 4 is right and a group of 5 is wrong. Okay, any problem?
No, ma'am.
No, ma'am.
No, ma'am.
Yeah, next rule.
Rule number 4, each group should be as large as possible.
So again, I've told you this. You remember I told you if there are, for example, you can see there are 4 ones together here. I should make a group of 4 here. Okay, and again there are these 4 ones here. I should make a single group of 4 ones here, and not one, 3 groups of 2s here. Okay, so the right grouping is shown here and the left grouping is shown here. And please see that overlapping is also possible. Actually, overlapping must be done if you are able to obtain a larger group by overlapping. Okay, so I could have settled for a quad here. Quad means a group of 4 here, and a doublet, which is a group of 2 here. But so I could have had these 2 groups. Okay, but uh, it is better to have 2 quads, even if it means overlapping has to be done. Any problem?
No,
No, ma'am.
ma'am.
Okay. Yeah. Continue, Dipali.
Each cell containing a 1 must be in at least one group.
So everyone has to be put in a group. Okay. We cannot leave a single one, even a single one. Okay. So in this case, this is shown to you, but this is a bit wrong. What we should have done is, although they are grouping these 2 together and this one singly, but this can be grouped with this one, as I explained to you in this previous step. Okay, using overlapping. Okay, so I should have, what we should have ideally done is group these 2 ones and make one group of these, and then another group of these 2 ones. Is this okay?
Yes, ma'am.
Yes,
Not
ma'am.
even a
Yes,
single
ma'am.
one can be left out. Okay, yeah.
Rule number 6, groups may overlap.
So this again I've told you. The same example is there. Any problem?
No, ma'am.
No, ma'am.
Okay, yeah. Seventh.
Rule number 7, groups may wrap around the table. The leftmost cell in a row may be grouped with the rightmost, or is it left? Rightmost
It's
cell,
the
and the
top. Yeah.
topmost cell in a column may be grouped with the bottom cell.
Yeah. So this is very interesting. Please see. You can visualize a Carnot map, as a circular thing. So you can actually, if you're drawing it on a paper, then you can fold it to join the 2 ends. Okay, that way you will realize that this column is actually adjacent to this column. Yes or no?
Yes, ma'am.
Yes, ma'am.
If I fold this in a circular fashion, okay, then we will realize that this is just adjacent to this uh, column. And I could have also folded it circularly along the x-axis, this axis that you see here. Yes, yes. And then we would have realized that this row is actually adjacent to this row. Okay, the other way also. That means that uh, in the first case, I, instead of forming a doublet of these two ones in one group and these two ones in another group, I would rather form a quad of these two joined with these two ones over the ends because they are actually contiguous. Any problem?
No, ma'am.
No, ma'am.
No, ma'am.
Very good. Similarly, when I fold along this axis, then what will I find? I can join this one with this one
Yes, ma'am.
and this one and this one. All these four can be joined together. Okay, all these four can be joined together to form a quad. So in this case, we are going to get only one quad. Okay, but there are two ways of forming it, looking at it. Okay, that we are either forming a quad this way, these two together and these two together making one quad, or you know, one, two. So this will make more sense in a four variable Carnot map actually. Okay, so these four corner cells can also be joined to form a quad. Is this okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, rule number 8.
Rule number 8, there should be as few groups as possible.
Now, this it might seem a little off the line for you because we have been stressing that please don't leave even a single one. No, even so make a group to include even a single one. Okay, but what this rule wants to say is that we should not make a group just for the heck of making. So in this case, please see, after these four have been grouped, these these two have been grouped with these two. So this is the first group that I've got. Okay, the next, what are left? These ones are left, right? Now to group these, I could have formed this group, which is wrong because I said I should go for the larger group. So what can be the larger group that I can form with this is this quad, which involves some overlapping, but that is okay. There is no problem. Is this clear?
Yes, ma'am.
Right. Now, after I've done that, I am again left with another one. How will I group that? I will group this one with, I can group either this one with this one or this one with this one. It doesn't matter. It doesn't matter. Okay. Now with these three groups, I have all the ones covered.
Excuse me, ma'am.
Yes.
Ma'am, the last line you said that the one which is left at the end.
Yeah. This one. You want me to explain this again?
Yeah, it will be part. And this
We can
third
make
one,
it a part. We need to group it. We cannot leave it. So either we can group it with this one.
ma'am, can't we make a quad here? Another quad, like
Yes, we can
these
also
two and
make
upper two.
another. Yes, we can also make another quad here. Yes. Okay. We can make another quad here. Yes. So after these three, but still, we get, so what are we going to get? We are going to get three quads here. Okay. So after these three groups have been made, now if somebody says that I can still group these two together and these two together and these two together. So should we write terms corresponding to these? Again, no,
No, ma'am.
we should not. Okay, we should not. Okay. Now, thank you, Dipali. Now, we are going to let us put our knowledge to use now and try to reduce some expressions. So the first question that you see on your screen is reduce the expression FABC this using a 3 variable Carnot map. Okay, so what am I going to do? The first step is to represent these. So you can see this is the min term 0, 0, 0, 0, right? This is 0, 0, 1. I put a 1, I put a 1 here, I put a 1 here, and then 0, 1, 1, which is 3, so I put a 1 here, and then 0, 1, 0, which is 2, so I put a 1 here. Is this clear?
Yes, ma'am.
Yes, ma'am.
So with these ones, what grouping is possible?
Quad. Quad.
This,
Quad.
this is the largest group that I can form, and all ones are being covered. Okay, so I will form this group. Now, after we have done the grouping, the next step was to write down the AND product corresponding to this group. Okay, so while grouping, please see, now since here in these four, please look at these combinations now. We find a B dash here and here. Yes or no?
Yes, ma'am.
Yes,
And
ma'am.
in the next two terms, I find a B. Yes.
Yes, ma'am.
So B and B dash cancel out.
Yes, ma'am.
Okay. So we will not write down the B term. Okay. We will not write down the B term in my final expression. Okay. Next, let us look at C. So this is C dash
Yes, ma'am.
and this
Ma'am.
is C
Yes, ma'am.
Yes, ma'am.
cancelled.
Yes, ma'am.
Yes,
Don't
ma'am.
need to look any further. Okay. That is also cancelled. Now let us come to the other axis and look at this. So what is this? This is A dash. Yes or no?
Yes, ma'am.
Yes, ma'am.
This A dash is constant for all these four.
Yes, ma'am.
Yes or no?
Yes, yes, yes.
So this will not cancel. So what will I write for this quad? I will only write A dash.
A
I will
dash.
only write A dash. And I have my answer. So you see, in a minute, I was given this expression and I arrived at this reduced expression. This is such a reduced expression. It cannot be reduced any further if you do your groupings carefully as per the rules. Is this clear?
Yes, ma'am.
Yes, ma'am.
Very good. To the new people also this is clear?
Yes, ma'am.
Very good.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Excellent.
Yes, ma'am.
Excellent, bit. Let us look at the next example now. So next time we have to represent these terms. So what are these terms? Again, this is a 3 variable Carnot map. So I draw the basic Carnot map. And now please see A dash B dash C, which is 0, 0, 1. So 0, 0, 1 is this, right? Then 0, I'm sorry, 1, 0, 0, which is 4. So this is 4. Then 0, 0, 1 again. Oh, and then 0, 1, 0, 1, which is 5. This is 4 and this is 5. I think इसका एक C प्राइम जो है ना वो यहाँ पे मिस हो गया. ओके, इसका एक सी प्राइम यहाँ पे मिस हो, देर this will need to be, I'm writing the expression again here. So this should be, so I'll do it later maybe. Just see that this should be a dash b dash c dash. Okay, so I get a 0. Okay, so 0, 1, then there was a 4, 2, 3, 4. Okay, and this is 5. 101 is 5. So this is 5. Okay, you can also locate them directly by looking at a dash b dash c. So we go to first a dash and then search for b dash c. So I put a 1 here. Okay, then a b dash c dash. So I go to a, and then b dash c dash. This is b dash c dash. So I put 1 here. Then a dash b dash c dash. So this is this term, and then a b dash c. So a b dash c. Is this clear? The representation is clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So what is the grouping possible here?
A chord.
Again, the largest grouping that is possible here is a quad, and this is a single group. So the next step is to write down the and term corresponding to this. Please see. Let us first focus on this axis this time. So a and a dash. A gets cancelled,
Yes, ma'am.
and in these two terms, c gets cancelled.
Yes, ma'am.
B remains constant. So I write B dash here. Any problem?
No, ma'am.
No, ma'am.
Okay, good. So I'll stop here for the day. It is already time. Next time we will see a few more examples of uh, optimizing the Boolean expressions using Carnot maps. And meanwhile, I want you to solve these expressions that we've solved today. These two examples that we've solved today using Carnot maps, I want you to solve them using Boolean algebra and see if you get the same answer. Okay?
Ma'am, excuse me.
Yes.
Ma'am, can you share this PDF with us if possible?
Uh, yes, I can, I think. This is under the copyright law of IRRL. So I can send you the link of the IRRL site. I'll rather send you the link of the IRRL site. It is free there. Okay. You may just have to log in, or maybe even not log in. I don't know. Okay. And you can get this PDF from there. Would that be okay?
Okay, ma'am.
Okay. Yeah. So I'm just going to share the link of the attendance. Please mark that and leave. And Aromo has sent me a problem she's had with one of the Boolean expressions. Aromo, with your permission, can I take it in the next class, please? I don't have that slide at the moment. Aromo, are you there? Aromo?
Yes, ma'am.
Yeah. So, beta, can I take your problem in the next class? Or let me just see. I may have to just find it. It was here in this Boolean. You just point out to me. I'm just running the PPT here. just running the PPT here. Please just point out which expression you had a problem in. This is okay?
Okay, ma'am.
This one?
Yeah, now say. Um,
This one?
the, let me see. Ma'am, none of those ones.
This one? You had a problem with this one, Aromo? You can write in the chat window if you're unable to speak.
No, ma'am.
Okay. Okay. So I will explain this. Please see. So we needed to simplify this. Okay. Actually, I saw that a different version of this file, I think, got to you people. Okay, the earlier version by some mistake that got uploaded. So I will upload this file. Okay, this is the right solution for this Boolean expression. Okay, please see. So when I have to solve this expression, how do we go about it? So this is the original expression. This is the original expression. So the first step, I simply use the law of identity on v and v dash and make it 1, and this disappears. What I'm left with is this. Okay. Now here I will open, in the next step, I will open this with the De Morgan's law. So what will I get? A dash or B dash. Right? Yes or no, students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, right. Now to proceed further, I will apply the distributive law. Okay. So what do I get? I get A dash and A dash, right? Then A dash B, then B dash A dash, and then B dash B. Okay, right? Now x dotted with x is x. So this is A dash. These two terms remain the same. Okay. And this is xx dash is 0. Okay. So what I'm left with is actually just these three terms. Okay. I can see A dash common here. So I've taken A dash common. What I'm left with is 1 or B dash. Yes or no?
Yes, ma'am.
And anything ended with the, anything odd with a 1 is?
1.
Anything odd with a 1 is 1. Okay. So what I'm left with is A dash. Okay.
Okay,
Is this
ma'am.
clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. So I want to thank Oromo for bringing this to my notice. Okay. And I will upload this uh, PPT. You can access it again. Okay. And I'm just going to be sending the attendance link to you. Please mark your present and then